I know, you need to read it. Of course I'm going to read it. Because I think that the ending is really good. The quickening hasn't happened. I'm feeling most of them are going to get their powers. Hearing that. You have to read. I'm kidding. I'm still 9% sure. So,
Guys, we're gonna look at
7. I don't know. I'm giving numbers.
I think so.
Oh yeah, it has a point thing. Can we do one with a point?
we're gonna do one. It's a little bit harder than that. You can go back and knock that one out. I was thinking like number 11. Okay.
Okay. That
So.
one has a point too.
So 11 says, look at this weird curve. What's the equation of the line tangent to the curve at 4, 1? So here's the equation of the curve.
It's confusing.
Okay, so I have no idea what that curve looks like. It's a very complicated form, but let's first confirm. Just suppose for a second that the question just said true or false. The point 41 lives on this curve. Does the point 41 lie on this curve? How do you check that? You just plug it in. So point 41, you would just see if you plug in 4 for x and 1 for y. Does the statement read true or does it read false? Well, 2 plus 4 does equal 6. So yeah, 4, 1 is on the curve. Does that make sense? Okay, is the point 5, 1 on the curve? No, because if you plug in 5 and 1, it wouldn't be true. It wouldn't be a true statement. So all we know is that some weird stuff's happening. No idea what the curve looks like. I do have a suspicion that when y is -1, there's something weird going on there. So maybe there's some kind of asymptotic behavior, but whatever. Say the curve. Again, we have no idea what this looks like. It could look like that. But all we're saying is that over at 4, 1, that point, oh, I drew that. That's so dumb. Sorry. I drew the point down before. So say the curve looks like that. Over at the point 4, 1, there's going to be a tangent line. And we can write the equation of that line. Does that make sense? So by the way, but let's just fast forward all the way to the end here. My final answer, we actually already know most of it, right? Because with point slope form, is everyone okay with that? Does that make sense? We already know, like, yes, no, maybe? So point slope form, because x is 4 and y is 1, all we're missing is this slope. So we have to find the derivative. Okay, ready spaghetti? For
Ready
derivative
spaghetti.
time? Oh,
I like this.
this guy, we need,
Third grader drawing the ground.
It's like a love potion.
This guy just killed us back here, Mr. Hall.
okay. We're gonna use the quotient rule for this term here. So it's like a over b, derivative is gonna be a prime b minus b prime a all over b squared. So 1 times 1 plus y minus y prime times x all over 1 plus y squared. Are there any questions on, that's just the derivative of this term right here. That's all that is. Okay. Now the derivative of this requires the product rule, yep. So 1 times y plus y prime times x. And how about the right-hand side? All right. So maybe someone can be really clever here and come up with the easiest. What's the easiest thing that we should do? What do you think the next step should be that would make our life easier? That is an option. We could simplify all this. What, Alyssa?
I like the Y.
We could, I think you guys are thinking of, oh, let's solve for y prime. That's certainly an option, but it's going to be actually a lot easier for us just to plug in the x and the y value that we care about. So,
Oh,
so remember, the point we care about, the point that we're wondering about is the point 4, 1. So of course, 4 is the x, and 1 is the y. And what this formula does is this formula right here, it's not simplified yet, but it relates the slope, y prime, to any xy pair that is on the curve. So this xy pair is on the curve, so I just plug in, everywhere I see an x, I'm going to put a 4, everywhere I see a y, I'm going to put a 1. So 1 plus 1 is 2. Y prime times x, and the x value is 4. And then down here, 1 plus 1 squared is 4. And then 1 times y, so that 1 times 1 is 1. And then we get another 4. Do we feel okay about that?
mhm.
Now, hopefully we agree that this looks a lot less scary and this looks easier to deal with than this.
Yeah.
So now you have one variable to solve for. So from here, it's actually a fairly straightforward algebra question. So it's sort of up to you. I would just divide these both by 4. Then I have no more fractions. So 2 divided, so I'm going to kind of skip over here now. So 2 divided by 4 is 1/2. Negative 4 divided by 4 is negative 1. So I just have a minus y prime there. Plus 1. Plus. Are we all cool with that?
Mhm.
Beeps. Hang on, let me turn my projector on. We'll check our answer with the computer and see if it makes sense. Okay, so 1/2 plus 1 is 3/2. And then negative 1 plus 4, negative 1y prime plus 4y primes makes 3y primes. And so when you solve that, you end up with a very simple answer, negative 1/2. Does that make sense?
Yep.
So it turns out that how do we check our answer? Yep, we're going to plug in our original formula into, sorry, ugly. I didn't want the parentheses were fine. I don't know why they were both. Okay. What's really interesting is earlier I thought there was going to be like some kind of asymptote at -1, but I guess there's no need for it because I guess there is a little hole there. That's kind of interesting. See that? So anyway, I guess y can approach -1, but it can't actually be -1. It's pretty fascinating. Anyway, what did we find? We said that there's the point 4, 1. Can I? Oh. Yes, there we go. And just eyeballing it, does it look like this tangent line would be about a -1/2 slope? Yeah, and plugging it in is very simple. And there we go. If we zoom in on that point, you can see its tangent. So there we go. That's kind of nice, right? It's a weird curve. Kind of strange.
Cool story.
Cool. It's a cool story, bro.
Oh my god.
Paul, I'm actually
Whatever.
your favorite student because I start off every email from when I got quarantined and stuff with bruh.
Yeah, bruh. Yeah.
Bruh.
Come on.
I sign all of my emails to Jay Hall's baby.
Let's look at one more, and then we'll have some work time. You guys can work on a few on your own.
I think the best email I've ever seen.
Why?
Okay.
J-Ho, you're the least scary teacher for me to email personally.
Thanks.
It's very easy to email you.
I could be actually response.
No, because some people I get very stressed about emailing. So
Like, next
yeah,
problem.
emailing is one of the things that gives me the most anxiety, but emailing J-Ho does not give me anxiety.
Oh, you think that's?
It's good. I'm not trying to give anyone anxiety here. You know?
I went to sign up for yesterday.
We're gonna look at 12. So if we are, if we're thinky winkies
Yeah.
about
Winky winky.
this question, you go, they're giving us a curve. I hope when you look at that curve, you can identify that like finding the derivative is actually going to be pretty easy for this one because there's no product rule, there's no quotient rule. It's going to be fairly straightforward. But then it's asking us to find 4 points. And stress the word point. What's a point? A point is a object that has two, it's an x and a y value. So you might be going, well, we've briefly talked about sort of like, oh, look at this equation. There are certain conditions you can talk about where, if this condition were met, then there might be a horizontal tangent line, sorry. But we haven't yet found an actual point yet. So let's look at what that looks like. So 8y minus 2x cubed y squared minus 6x plus 3. Great. Okay. So here's a question for you right off the bat. Is it easy to just come up with points that live on this curve?
Sure. I guess.
I mean, depends on which point.
Does it?
Like for example, if I just named a y, let's say, when y is 0. Is there a point on this curve where y is 0?
Yeah. Well, maybe.
Is that an easy question to answer?
Well,
No, that's extremely difficult.
No,
I don't
you're
know.
not giving us her
I
answer.
would say it's extremely difficult, but it's not easy. Oh, that's a cube.
It's a
Never mind.
cubic, yeah.
That is
so
extremely difficult.
with a
Just
computer,
kidding.
sure, with a computer it's easy, but all I'm pointing out is if I give you a y value and say, is there a point in this curve that has a y value of 1? You plug in 1s there, you're gonna have a hard time finding x values. But if I give you an x value, let's say I asked you, is there a point on the curve where say when x is 0, plug zeros in here, and now it's a quadratic.
Yeah.
That's pretty easily solvable, right?
Yeah.
I'm just trying to give you a little bit of a primer there, I guess.
Yeah.
So let's take the derivative.
All right.
8y prime minus 6x squared is equal to 2y prime minus 6 plus 0. Are we all in agreement on that? That sound good?
Mm-hmm.
Okay, so let's rearrange it. Bring this guy over here. So 8y prime minus 2y prime is equal to 6x squared minus 6. No objections to that, right?
Mm-hmm.
Just a little swappy.
Mm-hmm.
And now we're solving for y prime here. Let me ask this. Does it make sense why in this context we kind of have to solve for y prime, whereas like 5 minutes ago we were able to just plug numbers in? So hope that's clear enough. Because we want an expression, be able to look at that expression and say, when is that expression equal to 0? So anyway, so if I factor out y prime here, what I have is 8 minus 2y. And over here, I mean, I guess I could factor out a 6 if I wanted to. But You don't really have to. Let's leave it like this one. It's up to you. You can factor out 16. Okay, great. We've got our answer. And then maybe just to be super cool.
Amazingly cool.
Is that amazingly cool?
Wow.
Very good. Divide everything by 2 just to make
Amazing.
just to simplify. I know, amazing, right?
Wow.
Absolutely incredible.
Mind blowing.
So, let me ask you this. Do you see why there's going to be 4 answers? At least I think there's 4 answers. Unless I messed up right in the question. Just possible. Assuming I didn't. But do you see why because you might be looking at this going, wait a second, I'm kind of confused, right? I can see that there's, how many x values are there that make the slope be 0? There's 2. There's 1 and there's -1, right? Would make this equal to 0.
Mhm.
But the question is not how many x values are there, it's how many points. Well, let's say x was positive 1. Plug that in up there. Since it gives you a quadratic, that means there's going to probably be 2 y values that go with that x value. Likewise, when x is -1, there's going to be 2. So well, let me rewind. Does everyone understand why x being 1 or -1 would make us have a horizontal tangent line? Sure there's no confusion? Okay, great. So the first one. If x is 1, let's say x is 1. We're going to have 2 cases here. If x is 1, then we're also going to have if x is -1. Those are 2 different possibilities. And if everything goes according to plan, there's going to be 2 points that happen with this, and there's going to be 2 points that happen with this. That gives us our 4 points. Okay, let's let x be 1. We'd have 8y minus 2 equals y squared minus 6 plus 3, which we can rearrange. What do you get here? -3, so -1. Which is sadly not factorable. Sad. So sad. Like if you cry every time.
Yep.
You guys might know the answer to this. What do you think? What technique do you think I'm gonna use here?
Is it complete the square or whatever?
Complete the square. That is the most lit method. When the linear coefficient is even, everyone knows that, right, Jesse?
All right, fine.
We could use quadratic formula if you really wanted to.
I don't think anybody else wants to.
No.
I'm gonna complete the square.
Want me to tell you?
I'm sure Jesse remembers.
It's my favorite formula. I've had it for life.
Okay, let's review completing the square. It's sort of the
All right. My arch nemesis. Just kidding. It's not.
it's the forgotten method. I think it's a very nifty and interesting method.
It is. It is.
What number would I like to live here if I want this to be a perfect square? 16. I want it to be 16. Because
Two.
guys,
I'm
Okay,
just kidding.
let's look forward a little bit.
Yes, because 4 times 4 is 16. And
Yeah, because
yes.
one step down here, I want this to be y minus 4 squared.
Yes.
'Cause that's how I get the 8.
Yes.
So I want this to be a 16. So I have to add 17 to both sides. Okay. And what that does is I have 17 equals y squared minus 8y plus 16. Okay. So now HMU if question mark emoji.
Where do you get the 17 from again?
Did you just randomly want that there?
Not random.
16.
Nope.
Not random, but it's
Well, I've just heard my
I'll explain it again. Let's go backtrack. So the logic here goes, this guy right here is pretty close to being a perfect square. Okay, if this number here was a positive 16, it would be a perfect square. Okay, so what I do is I say, well, now of course, how do I know the number 16? How did I come up with 16? Well, I know that this is where I'm kind of going with the step ahead. And I was like, because this is an 8, I know that this has the potential to be eventually written as y minus 4 squared. Well, 4 squared is 16, so that's how I knew that I wanted a 16 there. So how do I make that a 16? Well, I'd have to add 17. Does that clear it up a little bit? Okay, so now, assuming I knew that, okay, I add 17 to both sides. My equation would have been 17 equals y squared minus 8y plus 16. That's what adding 17 did. It turned into this. When kids first learn this, usually they just learn this trick of, oh, it's half that number squared. You got to turn this number into half that number squared. And they do that trick. And they go, okay, I turned it into a 16. Now I recognize this as a perfect square. And then, so from here, the answer pops out. So you square both sides and add the 4. That makes sense? So your y values are 4 plus root 17 and 4 minus root 17. Those are the two
Yeah.
y values.
Yeah.
So if I'm writing my final list of points over here, one of them is x value of 1, y value of 4 plus root 17. Another one is 1, 4 minus root 17. Okay. Pretty enthralling, right, Cooper? Mm-hmm. That's pretty lit for you.
It's savage.
So savage, yes. Okay. Then you do it again for this. So let's say x is -1. So now my equation, I plug -1 in instead. I have 8y plus 2. Does everyone understand why it's plus 2 now?
Mm-hmm.
Because -1 cubed is -1. Equals y squared plus 6 plus 3. So now this all works out to y squared minus 8y 9. Now it's a 7. Is it going to work out?
Did you factor?
Can we go -7 minus 1?
Yes,
Yay!
that's what I did. It
It's
better be perfect.
factorable. I think it's factorable, so I'm having a.
You can also just.
I just-
You
Yeah, I
could.
completed the square. What
Me
the hell
too.
was I doing?
I
got in the brain mode.
Okay.
Yeah, you'd add 9 to both
Yeah,
sides.
yeah,
You
yeah,
can
yeah.
complete a square. It's interesting to look at how that works out. Yeah, you add 9 to both sides, you get square root of 9 plus 4. So 7 and
Yeah, which is.
this one happens to be factorable,
I
so
forgot to add 4.
oh that's nice.
I don't.
So-
Yes. I forgot to add 4. Those are wise.
So that means my other points are -1, 1, and then -1, 7. Isn't that a wacky collection of points?
Yes.
Wacky.
Oh, great. Computer.
7 and 9.
Was it cubed? What's cubed?
When in doubt.
Ooh, that's a nice elliptic curve right there.
That's a nice one.
The elliptic.
What?
Puzzle piece.
A puzzle piece, yeah. Let's look for our points. There's -1, 7. There's -1, 1. There's 1, 8.123, and then 1, -0.123. With my amazing powers of calculation in my head, I'm going to calculate. I bet you that 4 plus the square root of 17 is 8.123, roughly.
You're a genius.
Probably a genius. You can confirm that if you want, but yeah,
It is, yeah.
that's pretty neato. Maybe,
Need a
maybe not.
burrito. Should we move the camera when there's
Yes.
Desmos?
Oh, this is Mr. Desmos. Sorry. I'm just a rookie at this, man. That's all. I just.
You
Tell me
should,
that it started for a pandemic when you got your.
well, you should do it like GoPro style.
So for the grifter, you know, every time we're doing these implicit curves, I'm probably going to type it into Desmos and then confirm the answer. So you can safely assume that every question you can confirm. But oh, by the way, guys, for $1 billion, at what y value would this thing have the vertical tangent line?
Oh, 4?
4,
Boom.
right?
Ah, you're rich.
No, because so the question of when does it have what does horizontal tangent line mean? Horizontal tangent line means that y prime is equal to 0, which means like the top of the fraction is 0, the slope is 0. But what about a vertical tangent line? Well, if you think about a vertical tangent line, it's going to be, you know, slope is rise over run, right? Well, so this is kind of like rise over run in a sense. If the run is 0, you're going to have that vertical tangent line. So there's a bunch of questions on your problem set that say, maybe what condition is necessary for this curve to have a vertical tangent line? What you're going to do in that case is look at the denominator of your formula and be like, oh, what would make that 0? Well, if y was 4. And you can see on this graph here, that point right there, if y was 0, or sorry, if y was 4, my bad, there'd be a vertical tangent line there.
Whee!
Carlo, you have a derivative in respect to y, would this be still, would this be the same way as positive? You're just looking at the top.
Yep, exactly.
Would it just be flipped over
But if there is a slide that is perfectly straight,
and then set it equal to 0?
are you sliding down it or are you just falling?
Did you try that?
That's
Anyway, we're
with
gonna-
your butt's touching
I'll run it through real quick if you want,
But if
see if
you're
it
like
works.
hands touching the
Anyway, guys,
are you sliding
knock out some
down?
questions on your assignment. I can talk to you individually if you're stuck.
What if you have like a hand and a foot, so it's like